Here are the answers for many of the Chapter 4 review questions. The questions that are just fill in the blank or vocab questions, I'm not going to write out in the video. You can find those answers on your answer key page. For number 3, we're asked to simplify this division problem. The first thing we need to interpret is what is the numerator and what is the denominator of the division problem. The question is intending for us to group this entire piece as the denominator. So let's rewrite this in fraction form, and at the same time we're doing that, let's distribute this 3 to all of the factors in the parentheses. Start with the 4. 4 to the third power makes 64. Now the c, we get c to the 6, and now the d, d to the 9. Now divide. Let's put all of this in the denominator, and while we're doing that, let's distribute its exponent to all of the factors that are inside of those parentheses. Don't forget there's a 2 out at the beginning as well. So start with the 8. 8 to the second power is 64, and 2 times 64 is 128. Now the letter A, we get A to the second power. Now letter C, we get C to the 8th power. And now the letter D, D to the second power. Now we can reduce our coefficients. 64 over 128 reduces to 1 over 2. There are some A's in the bottom and there are no A's in the top, so our final answer will have A to the second in the bottom. Okay, now the letter C. There are 2 more C's in the bottom than in the top. So when we subtract them, we will have C to the 2 left in the bottom. Now the letter D, when we subtract those, we get D to the 7 in the top. So here's the answer in simplified form. Number 4, we have a product, and at every time, the base is an 8. So here's the first exponent, here's the next exponent, and this last exponent is a 1. The rule about multiplying things with the same base is to write the base, add the exponents. 4n add 3n is 7n. Negative 1 plus 1 cancels, and then plus 1 again makes a positive 1. So here is the answer in simple form. Number 5, this time we have a division problem. Let's write this with a numerator and denominator. So we have the negative 2n squared on top over, and then 6n to the 6s on the bottom. Now let's reduce. Negative divided by positive is negative. 2 over 6 reduces to 1 over 3. And now for the letter n, let's use the rule about subtracting the exponents. So we have n to the 2 minus 6s. Here is simple form. If this looks weird to you, you could write it like this. Negative 1/3 and then n to the 2 minus 6s. Either of these is correct. Next, number 6. We have a product, but before we can multiply, we need to distribute these exponents to the things inside the parentheses. So start with this b. Take the exponent you already have and multiply by this exponent. We would get 3c plus 3. Now over in here, we have our negative sign raised to the second power. That makes a positive. Now let's work with the letter b. Take the exponent you already have and multiply by the other exponent. 1 times 2 is 2, and negative 3c times 2 is negative 6c. Now we can do our multiplying. They both have the same base, so the rule is to keep the base and add the exponents. 3c plus negative 6c is negative 3c. And a 3 plus a 2 makes a positive 5. So here is that answer. Number 8, we want to square the binomial. The fast way is to square the first term, double the product of the 2 terms, and square the last term. Number 9, let's multiply the 3 binomials together using FOIL repeatedly. Keep the x plus 5 out at the beginning temporarily and use FOIL on this part here. We will get x plus 5 times, we're going to get a trinomial when we do FOIL. X times x is x squared. X times negative 3 is negative 3x for the outer product. Negative 2 times x is negative 2x on the inner product, and those combine to negative 5x. Now last, negative 2 times negative 3 is positive 6. Now let's use the distributive property twice. Start with the x and distribute it to all three of those terms. X times x squared is x cubed. X times negative 5x is negative 5x squared. And x times 6 is positive 6x. Now move over to the 5 and distribute it to all three of these terms. 5 times x squared is positive 5x squared. 5 times negative 5x is negative 25x. And 5 times 6 is positive 30. Now combine like terms. We have x cubed at the beginning. The x squared terms cancel away. The 6x minus 25x makes negative 19x. And there's a positive 30. Number 10, we can use the distributive property more than once. We have the same situation as the one we just had. It's just our binomial is written after the trinomial. If that bothers you, put the binomial out here at the beginning. However, to make it even faster, we might recognize that this fits one of our special cases. The special case that this fits is the difference of cubes. 1 minus 27t to the 6th power. When we would have a difference of cubes like this and we were asked to factor it, we would make a binomial times a trinomial. And we would get this number here by doing the cube root of 1, which is 1. And we would get this number here by doing the cube root of this, which is 3t to the 2nd power. Number 11, we're given two numbers and asked to find the GCF and LCM. So what is the greatest number that's a factor of both of these? If we prime factor these numbers, that will help us find the GCF and LCM. 186 is equal to 2 times 93. But this is equal to 2 times 3 times 31, because 93 is equal to 3 times 31. 31 is a prime number, so we're done. 124 can also be divided by 2. This can be written as 2 times 62. But 62 is 2 times 31. Here is the prime factorization of 186, and here is the prime factorization of 124. That will help us find our greatest common factor. Is 2 common to both of them? There's a 2 in our GCF. Is 3 common to both? Nope, there is not a factor of 3 over here. Is 31 common to both? Yes, it is. Multiplying these together, we find out that our greatest common factor is 62. Both of the original numbers would divide evenly by 62. We can use our prime factorization to help us get our LCM. Take every factor from the first number. 2 times 3 times 31. Now go to the other number and see if there are any factors we haven't yet written down. We don't yet have another 2. So let's include another 2 on that list. Now multiply these together on a calculator. The result is 372. That is the least common multiple of both numbers. 186 times 2 is 372. And 124 times 3 is 372. It's the smallest number that both of these can be changed into through multiplying. Number 12, same kind of question. Let's get GCF and LCM. Starting with greatest common factor. What is the largest number that divides into 8 and into 6 and into 12? That's a 2. Now let's work with the variables. Is there an R in all of them? Nope, no R's here. Is there a V in all of them? Yes, there is. What's the most amount of V's that can divide into all of them? The middle one restricts us to only v squared, because that's all the v's that are there. The other ones have enough v's to divide them by v squared. Here is our GCF. Okay, now our LCM. Let's build it by working with the numbers and then the variables. What is the least common multiple of an 8, a 6, and a 12? That would be 24. Because 8 times 3 is 24, 6 times 4 is 24, and 12 times 2 is 24. From the first number, we need to have an r squared in our LCM. And in neither of the other numbers are there more than 2 r's. Okay, now the letter v. From the first one, we need v cubed. That's enough to take this one into account. But in the last one, we need v to the 5th. So we actually need v to the 5th in our LCM. Are there any other letters of the alphabet that we need in our LCM? Yes, there is. We need an x. We have to have x cubed in our LCM. Number 13, we're asked to factor this. The first step of factoring is to look for greatest common factor. They're all even, so they will divide by 2. Factor a 2 out the front. Now let's see if this trinomial factors farther. The first number is a perfect square, and so is the last number. So I'm wondering if this is a perfect square trinomial. The square root of 36s squared is 6s. The square root of 1 is 1. Is 12x twice the product of 6s and 1? Oops, I'm sorry, this should be an s here. Is 12s twice the product of 6s and 1? Yes, it is. This is a perfect square trinomial. So you put one set of parentheses with squaring. Fill in that 6s and that positive 1 that we had figured out. Number 14. This has a common factor of an m in both places and an n squared in both places. So start by factoring out n squared. That's called a GCF. And let's figure out what we have remaining. We would have 9x to the 4th, and then a minus, and over here we would need the y squared. Looking in the parentheses, this is a difference of squares. So we have our mn squared, and then for a difference of squares, we'll get 2 parentheses. Let's do some square roots. What's the square root of 9x to the 4th? It's 3x squared. What's the square root of y squared? It's a y. So we have positive y and negative y. Number 15, we have a trinomial, but it doesn't go in decreasing order of degree, which will make it harder for us to recognize factoring patterns. Let's change the order of the terms. Put this one first because it has the highest degree in the variable a. Then put this term. This has the next highest degree in the variable a, and then put the constant term. This trinomial has a perfect square term at the beginning. The square root of that is 4a squared b squared. And it has a perfect square on the end. The square root of that is 1. Is the middle term twice the product of this times this? Yes, it is. So this is a perfect square trinomial. One set of parentheses squaring on the outside. Fill in those square roots that we had figured out. And the middle gets a minus sign because of that minus sign. Number 16, we have 4 terms, so we're thinking grouping. But if you group it as it is right now, there's not going to be any GCF for those terms. We need to change the order of the terms. Let's keep the 2n squared out at the beginning and follow it up with the minus 2n. Then put the positive cn, and then put the minus c. Now let's group them in binomials. In our first binomial, we can factor out 2n, and that leaves n minus 1. On this one here, it looks like we can factor out a c, and that would leave n minus 1. So we have an n minus 1 common to both places. So we write that down, and then write the other numbers, the 2n and the positive c. Number 17 also has 4 terms, so let's use grouping. I think we'll be okay if we leave it in the order that it is right now. Group this and group this. The only GCF of x minus 5 is a 1 times x minus 5. Over here, they both have an a, so we can factor out a positive a, leaving x minus 5. Notice there's an x minus 5 common to both, so factor that down. That's called the greatest common factor. And then in parentheses, put the other numbers, the 1 and the positive a. Number 18, this has 4 terms, so let's try the grouping process. But I think we're going to need to rearrange the terms. Let's put the y to the 4th power first, then the positive y cubed, then the positive 125y, and then the positive 125, and group as a pair of binomials. In the first binomial, they both divide by y cubed, and that leaves y plus 1. Here and here, we can divide out a positive 125, and that leaves a y plus 1. So in common, we have our y plus 1, and then the other things are a y cubed and a plus 125. Now, y cubed plus 125 is a sum of cubes, so it factors farther. So here's our y plus 1. Now let's make the parenthesis pattern that you use for a sum of cubes. A small parenthesis and then a longer parenthesis. The cube root of y cubed is y. Keep the positive sign, and the cube root of 125 is 5. Now square that y. You get y squared. Change that sign to a minus. Take the product of those things. You get 5y, and then square the 5. You get positive 25. So here is the final factored form on that one. Number 19. There is a GCF of 2. They all divide by 2, leaving m squared plus 15m plus 54. Now let's factor the trinomial using FOIL. We have m times m was our m squared. Now we need 2 numbers that multiply to 54 and add up to 15. How about a positive 9 and a positive 6? Number 20, we have a trinomial. Let's try FOIL again. We have c times c is our c squared. And now we need 2 numbers that multiply to negative 81d squared. They're both going to have a d on them. Now to multiply to negative 81, we need a positive and we need a negative. And the 2 numbers we choose have to add up to negative 24. So we don't want to use like 9 times 9 because that wouldn't get us our negative 24. 27 times 3 makes 81, so with a 27 and a 3, can we get a 24? I think we can if we're careful with the symbols. Let's put the 3 with the plus sign and the 27 with the negative sign, because a negative 27 and a positive 3 combine to a negative 24. Number 21. Here's another trinomial, and there's no GCF, so let's try using FOIL. What times what makes 8h squared? It might be 4h times 2h. Now if we can't make this work, we'll erase it and try 8h times 1h. Now we need numbers that times to negative 24. One of them will be positive and one of them will be negative. And there's different ways to make 24. It could be a 4 times 6, 3 times 8, 2 times 12, or 1 times 24. We need the middle to turn out to be positive 61. So let's try some numbers in there, and if they don't work, we'll erase and just rearrange where the numbers are positioned. Let's try doing negative 3 times a positive 8 and see what happens. Our outer product is 32h. and our inner is negative 6h. And these combine to 26h. That is a long way off of being 61h. I'm concerned that my 4h and my 2h weren't right to begin with. Let's erase and try 8h times 1h. Now let's try these numbers again, and if it doesn't work, we'll just rearrange where we put them. Let's try a negative 3 times a positive 8. The outer product is 64h. The inner product is negative 3h. And these combine to 61h. That's what we wanted. So here's our factored form. We got that after 2 tries. Number 22 is another trinomial. So let's try FOIL. To make 9n squared, it could be 3n times 3n, or it could be 9n times 1n. I'm worried that using the 3n and the 3n isn't going to ever get me to the 113n. Maybe I should have used 9n times 1n. Let's erase this and try again. 140 and negative 3. 140 times negative 3 is negative 420. The outer product is negative 27n, and the inner product is positive 140n, and those combine to 113n. So here is the factored form. That problem was really tough because there were so many possibilities that you had to try in order to get the middle to turn out to be 113. Now number 23, we're back to doing a greatest common factor in LCM again. It would help if we had factored form. So let's factor the first one as 3 times n minus 3. This one's already factored. This one here is not in the right order. Let's rewrite this as negative n plus 3, and then because it has a leading coefficient of negative, we can factor out a negative 1. Now let's get our GCF. There's a 3 here and a 3 here, but not a 3 over here. There's an n minus 3 here and over here, but not in the middle. So the greatest common factor is a 1. Now let's build the LCM. Let's take both of these factors, the 3 and the n minus 3. Now look at the other things to see if we're missing any factors. We already grabbed the 3, but we don't yet have an n. So let's put an n on this. And now over here, we've already grabbed the n minus 3. So here is our LCM. If it bothers you that the n is here on the end, you could have squished it right after the 3. Number 24, let's factor these expressions. This one is b plus 2 times b minus 2. This one right here is already factored. There are 2 factors of b minus 2. This last one has a GCF of b, so we get b times b minus 2. Let's get our greatest common factor. There is a b minus 2 in all the terms. That's the GCF. Now let's create our LCM. We need a b plus 2 and a b minus 2. That takes care of both of those. Now looking here in the middle, we notice that writing a b minus 2 only once is not enough of them. We need 2 of them. So let's give it an exponent. And then looking over here, we've already got the b minus 2, but we don't yet have a factor of b. So let's toss a b onto the front end of that. Here is our LCM. Number 25, we're asked to solve the equation. The technique that we learned when the equations go to the second power is to get a 0 on the right and factor the left. Let's subtract the 9a squared x from both sides. We get x squared minus 9a squared x, and it's equal to 0. Now let's factor this. Both of them have an x, so we can factor an x out the beginning. And we're left with x minus 9a squared. And that's equal to 0. Now take both of those factors and set them equal to 0. So we have x equals 0, or the x minus 9a squared is equal to 0. This first one is already solved, and this one here can be solved by adding the 9a squared to the other side. We get x equals 9a squared. So there are two answers, x equals 0 or 9a squared. Number 26, let's use that same technique. There's already a 0. We can factor this side. Let's factor out an x. That leaves 9x squared minus 16. This is a difference of squares, so it factors more, as 3x plus 4 times 3x minus 4. Now we can take our three factors and set them all equal to 0. So x equals 0, or 3x plus 4 equals 0, or 3x minus 4 equals 0. This first one is already solved. For this one here, subtract 4 from both sides. We get 3x equals negative 4. Now divide by 3. We get x equals negative 4 thirds. Okay, over here, let's add 4 to both sides. We get 3x equals 4. And then divide by 3. We get x equals 4 thirds. So there are three answers. There's x equals 0, or negative 4 thirds, or positive 4 thirds. For number 27, let's use the same technique. If we subtract the 6x, we can get a 0 on the right side. Now let's factor the trinomial using FOIL. X times x is x squared. We need two numbers that multiply to negative 16, so one's positive and one's negative. We want them to combine to negative 6. How about a negative 8 and a positive 2? Now take each factor and set it equal to 0. From the first one, we'll get x equals 8, and from the second one, we will get x equals negative 2. Number 28, let's use the same technique. On the left side, they all divide by 6, so we can factor out a 6. Now factor the trinomial using FOIL. Two numbers that multiply to 12 and they add up to negative 8. How about a negative 6 and a negative 2? Now take each variable factor and set it equal to 0 and solve. From the first one, we'll find out that x equals 6, and from this one, we will find out that x equals 2. Number 29, let's go with the same technique. Let's factor that trinomial. There's different ways to make 12x squared. It could be 4x times 3x, 6x times 2x, or even 12x times 1x. Let's try positive 9 times negative 4. I don't know if it's going to work, but at least it'll give us an idea if we're close. Our outer product is negative 16x. Our inner product is positive 27x. These add together to 11x. Hey, that's what we wanted. That was an excellent guess using the 9 and the 4. Now take each of those factors and set them equal to 0. And solve each of these equations. This one makes x equals negative 9/4. And this one makes x equals positive 4/3. Let's try some factoring. This makes x times m plus n. On this side, we have 2 times m squared minus n squared. That's a difference of squares, and it factors. So we have x times m plus n equals 2 times m plus n times m minus n. Notice the common factor of m plus n on both sides. Using division, that will cancel away. So we have x equals 2 times m minus n. You could leave the answer for x like this, or you could do the distributive property and discover that x equals 2m minus 2n. Either is fine, but we have solved for x. Number 31, we have a word problem that talks about a square and a rectangle. We're asked to find the length of the sides of the square, so that's where I put the variables to represent those unknown sides. We're told that the length of the rectangle is 12 longer than the side of the square, and the width of the rectangle is 2 less than the side of a square. Now we're given a sentence about the areas. The area of the rectangle is, so let's make an expression to represent the area of the rectangle. X plus 12 times x minus 2. The word is an equal symbol. The sentence says double the area of the square. So as an expression, that would be 2 times x squared. This expression fits the sentence in the word problem. Let's multiply these binomials together. X times x is x squared. Negative 2x plus 12x is positive 10x, and 12 times negative 2 is negative 24, and that's equal to 2x squared. To solve an equation that has squaring in it, let's do that technique about getting a 0 on one side and factoring the other side. We can subtract x squared from both sides. We will have 10x minus 24 equals x squared. Now let's subtract the 10x and add the 24 to cancel these away, getting a 0 on the left. We'll have x squared minus 10x plus 24 equals 0. Now we can factor this as x minus 6 times x minus 4, and that's equal to 0. Solving for both of these, we get x equals 6 and x equals 4. Let's try those in the original problem. Can the sides of a square both be 6? Does that make sense? Yeah, that's possible. So the square could be 6 inches by 6 inches. Let's try our other value to see if it's possible. Can the sides of that square be 4? It's possible to have a square that's 4 by 4. If x is a 4, does that create any problems on the rectangle? We would get 16 by 2. Nope, it's possible to have a rectangle that's 16 by 2. So our other answer is a 4-inch by 4-inch square. Number 33, we want to graph this inequality on the number line. The technique that we learned is to have a 0 on one side and factor the other side. We can factor out a 3k, and that leaves 2 minus k, and that's less than or equal to 0. When you have two things multiplied together, and the answer is less than or equal to 0, you can interpret this as being negative. There are some cases to consider. Case number 1, the first one might be positive and the other one might be negative. And case number 2, the first one might be negative and the other one might be positive. Let's go back to case 1 and solve these expressions. Divide both sides by 3 and you get this. And here, to solve for k, you would subtract 2 and then divide by negative 1. K is greater than or equal to 0, and at the same time, it's greater than or equal to 1. Just this single expression fits both of those statements. Now go over to case 2. Let's divide by 3. And over here, you need to subtract the 2 and then divide by negative 1. The fact that I got a 2 here points out to me that on the previous one, I should have had a 2. k is less than or equal to 0 and at the same time less than or equal to 2. That can be summed up with the single expression k is less than or equal to 0. Connecting case 1 and case 2 is the word or. So we can graph both of these parts. Here's 0, here's 2. Close dot on 0 and shade less than. Close dot on 2 and shade greater than. Number 34. Let's distribute the 4 to both terms and then subtract them to get a 0 on the right. We get v squared minus 4v minus 12 is greater than or equal to 0. Now factor the trinomial. We can go with v minus 6 times v plus 2. We have two things times together. The result is greater than or equal to 0. You can interpret this as meaning positive. So there are some cases to consider. Case number 1, both things might be positive. Case number 2, they might both be negative because a negative times a negative is greater than 0. I'll go back and solve these. This is v is greater than or equal to 6, and v is greater than or equal to negative 2. This can be summed up with the single expression, v is greater than or equal to 6. Now over here we get v is less than or equal to 6, and v is less than or equal to negative 2. This can be summed up with the single expression, v is less than or equal to negative 2. Now connecting case 1 and case 2 is the word or. So let's graph both of these pieces. Here's negative 2 and here's 6. Close dot and shade less than. Close dot and shade greater than. Number 38, we have long division. So focus on leading terms. 2n times 3n squared is the 6n cubed. 3n squared times negative 5 is negative 15n squared. Now subtract them. Negative 31 subtract negative 15 is negative 16n squared. Bring down the next term. 2n times negative 8n is the negative 16n squared. And negative 8n times negative 5 is positive 40n. Now subtract. 34 subtract 40 is negative 6n. And bring down the next term. 2n times negative 3 is negative 6n. And negative 3 times negative 5 is positive 15. And now subtract. 10 take away 15 is negative 5. This is our remainder. So on the end you go plus, and then you write that negative 5 on top of the divisor. The answer to the division question is on top of the bar. Finally, number 41, we're asked to factor this. And it has 4 terms, and it doesn't look like grouping is going to work. So to factor this, we need to find a beginning factor. We can use the factor theorem to help us. Maybe z minus 1 is a factor. If it is a factor, then when we substitute a 1 in place of z, this has to turn out to be 0. Let's do that and see what it makes. It makes negative 45. So z minus 1 is not a factor of the original polynomial. Maybe z minus 2 is a factor. If it is, then if we substitute in a 2, we're going to get a 0. Let's do that and see what we get. Let's type that on the calculator, see what it makes. This makes negative 80. That's worse than we had before. What that's telling me is that our factor is not going to be z minus a number, but instead it's probably z plus some number. Let's try z plus 1. If z plus 1 is a factor, that means when you substitute in negative 1, you will get a 0. Let's fill in a -1 and see what it makes. This makes 7. That didn't work, but that's a lot closer. Maybe z plus 2 is a factor. Let's fill in -2 and see if it works. Take a calculator and type this in. And this turns out to be 0. That tells us that z plus 2 is a factor of the original polynomial. Now we can use long division to find out what's the other factor that goes with z plus 2. So we have z plus 2 divides into, and then fill in our polynomial. Z times 2z squared is the 2z cubed. And 2z squared times 2 is positive 4z squared. Now subtract. -7 subtract 4 is -11z squared. And bring down the next term. Z times -11z is -11z squared. And -11z times 2 is -22z. Now subtract. We get -6z. And bring down the next term. Z times -6 is -6z. And -6 times 2 is -12. And when you subtract, you get 0, which we knew we had to get because we had already verified that z plus 2 was a factor. So what we've discovered is that it factors into z plus 2 times 2z squared minus 11z minus 6. Let's factor this trinomial using FOIL. We have our z plus 2 and then 2 sets of parentheses. 2z times z is our 2z squared. Now we need numbers that multiply to -6. So one of them's positive and one of them's negative. Could be a 3 and a 2 or a 1 and a 6. I'm going to go with +1 and a -6. And the reason is that the outer product is -12z and the inner product is +1z, and those combine to -11z, which is what my middle term is. So here is our factored form.